Own, build, live. You probably think the metaverse is just what you see on the surface, right? A pristine digital city where your avatar can move around, buy land, equip assets, and it's all completely seamless. But hold on a second. What happens when we freeze the frame? The illusion kinda glitches. The interface peels away into code, that code dissolves into data streams, and right beneath it all, nodes start to glow. Wallets connect, smart contracts execute, token flows are just pulsing invisibly in the background. What if the real system isn't that visual world at all? Because behind literally every avatar, every digital asset, and every single interaction, there's this massive infrastructure that you never actually see. It's a hidden web of validators, protocols, and marketplaces. So really, the question we should be asking isn't what is the metaverse, it's who actually controls it.
Welcome to today's Explainer. We're going to map out the exact architecture that makes these digital universes possible, and we'll expose the fragile, highly complex ecosystem that dictates true ownership.
Before we dive in, please note, this explainer on the channel Blockspawn's Funds is created for educational and informational purposes only and does not constitute financial or investment advice.
All right, let's jump into Section 1, the Metaverse Illusion.
So to really understand the reality of digital property and interaction, we kind of have to start by peeling back the visual interface. You probably think the metaverse is just these colorful 3D avatars running around on virtual land, waving at each other using emotes. We are so conditioned to look at the screen and just see a game. But honestly, that is only the experience layer. It's basically a beautiful rendering engine mask that's covering up a highly complex ecosystem right underneath. If we want to understand how the system actually operates, we got to stop looking at the avatars and start looking at the code.
Which brings us to Section 2, uncovering the hidden layers. If we really want to understand digital sovereignty, we need a map. And here is the true stack. It's a 5-layer model. Now at the very top and bottom, you've got the things you interact with directly, right? The hardware layer, like your VR headset, and the network layer routing your 5G data. Then, sitting in the middle, you have the platform and application layers, and they manage the 3D physics and gaming events. But sitting right at the critical foundation is Layer 5, the economic and blockchain layer. Guys, this is the engine room. This is where token economies, decentralized finance primitives, and smart contracts actually dictate asset portability. This specific layer is what transforms a simple video game into a functioning economy.
And the backbone of this entire economic layer relies on smart contracts. As you probably know, these are autonomous computer programs executed directly on a blockchain. They automatically enforce obligations using strict programming logic. That means they don't need a centralized intermediary, no middleman sitting there saying, yep, this transaction is valid. Running on systems like the Ethereum virtual machine, these contracts execute the exact logic of who owns what. They're tracing transactions as tokens and NFTs move seamlessly across addresses. They act as the absolute tamper-proof law of the digital land. But there is a massive catch to relying on this technology. And that leads us into Section 3, the scalability problem. So here is exactly where the seamless illusion of the metaverse just shatters. Because structurally speaking, blockchains alone cannot actually run a real-time virtual world. 15. That is roughly the number of transactions per second that Ethereum's base layer can handle. Just 15. I mean, when you consider the demands of an immersive, global digital world with millions of users moving, trading, updating their status, interacting all at the exact same time, 15 transactions a second creates a massive system-breaking bottleneck. A truly global metaverse would demand thousands, if not millions, of transactions a second.
The really crucial point here is the latency reality. For an experience to feel truly immersive, you need single to low double-digit millisecond latency. Multiplayer games demand sub-30 millisecond response times just so you don't experience crazy lag. Now sure, 5G helps reduce latency a bit, but it only solves the last mile from the cell tower to your device. The core architectural problem is that blockchains require consensus across thousands of independent nodes worldwide just to verify a state change, and that causes massive delays. When users need real-time rendering and instant actions, the latency limits of decentralized networks threaten to make the entire system completely unusable.
Let's move on to Section 4, Identity and Storage Systems.
So, if the base blockchain is too slow and way too expensive to host an entire world, developers have to essentially duct tape the ecosystem together. And the first major workaround is data storage. Storing heavy data like the actual 3D models of avatars or high-res textures directly on-chain, it's financially impossible. It would cost astronomical amounts in network fees. So instead, the system relies on off-chain decentralized networks like IPFS or Arweave. The blockchain only stores a tiny cryptographic hash, basically a digital fingerprint, that points to where the actual file is kept off-chain. So your NFT isn't the image itself, it's really just a receipt pointing to a server somewhere else.
And it's not just the assets that are modular. It's you. The Bring Your Own Identity, or BYOI architecture, places your Web3 wallet perfectly at the center. It ties together your on-chain transactions, your off-chain credentials like a passport or an event ticket, and your social signals, all into a single sovereign identity. You aren't creating a new account for every game anymore. Your wallet acts as a universal passport that carries your history, your assets, and your permissions across the entire digital ecosystem.
But to make these complex identity and asset networks survive without totally jamming up the main blockchain, the infrastructure relies heavily on Layer 2 scaling. These are solutions like Optimistic and ZK rollups. Think of them as high-speed execution venues. They process the heavy lifting, thousands of transactions off-chain at blazing speeds and for a fraction of the cost. Then they bundle them all up and anchor the cryptographic proof back to the Layer 1 blockchain. In this architecture, the main blockchain isn't the computer running the game. It's actually just the Supreme Court settling the final balances.
Now, for Section 5, the economics of control. All right, so we need to look past how the system functions technically and actually analyze the structures of economic dependency. The sandbox platform architecture is a perfect example of this, and it reveals a pretty startling truth. Even in decentralized platforms that champion Web3 values, they still heavily rely on centralized infrastructure. Right there in the middle sit AWS servers. Amazon Web Services are routing the blockchain data. They're monitoring the smart contracts and pushing changes through back-end APIs just to deliver the experience to your browser. Your assets might be decentralized, but the lens through which you view them is entirely centralized. If AWS goes down, your decentralized world goes dark.
So, we are ultimately left with this hybrid reality of ownership where true self-sovereignty is heavily constrained. First off, smart contracts require gas fees. You literally have to pay to prove you own something or to move it. Second, to make the system usable, platforms use abstracted non-custodial wallets that hide your private keys to protect you from yourself. That sacrifices pure control for convenience. Third, true interoperability is totally fractured. Different chains and namespaces just don't smoothly talk to each other. And finally, marketplaces act as extraction layers through hidden fees and royalties. You might own the digital item, but you are still playing inside someone else's economic toll booth.
Which brings us to our final part, Section 6, Who owns the system?
As all these layers converge into a unified system map, we really have to step back for a second. The Metaverse is not a game. It is not just an experience. It is an emergent system defined entirely by the infrastructure governing ownership, identity, and value. The rules of this world aren't written in the visual interface. They are written in the hidden layers of smart contracts, centralized servers, and extraction layers we just explored. Zooming out to this global network of interconnected systems, I want to leave you with this final thought to consider the next time you log in. The real question isn't what you can do in the metaverse. It's who controls the infrastructure that defines what's possible. Thank you for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.